All right, welcome back to statistics. We are in the middle of our conversation about standard deviation and measures of spread in general. Okay, so one thing that I would like to ask you is spread continued is what kind of number can a standard deviation be? Okay, by that I mean, can a standard deviation be negative? Right. Well, let's look at the formula. Right. Say S is now. We'll say S is equal to X minus X bar squared. Those numbers aren't negative, right? Divided by n minus 1. This is a count, so that's not negative. Now we took the square root. We're taking the square root of a positive number. This is going to be positive. Okay. So can the standard deviation be negative? No. Could it be 0? Well, what if we had a really boring sample size? Like, what if I had like 10 students that all had all of their fingers? Okay, and I asked, how many fingers per hand do you have? 5, 5, 5, 5, 5, and all of them happen to have 5 fingers. Right? That's a boring data set. Okay, what's the average? 5. What's each value minus its average? 0, right? So if I add up a bunch of zeros, square them, take the square root, am I gonna get 0? Yeah. We usually don't do statistics on things like this. Okay, but it is possible. Okay. How about range? Right, it's max minus min. So, well, it's a bigger number minus a smallest number, of course. What if they're both negative? Okay, what if they're both negative numbers? So what if I find that the two extremes of my data, -8 and -30? I'm collecting temperatures in Antarctica or something. So the first question I have for you is, would you rather be $8 in debt or $30 in debt? And most of you will say, I'd rather be $8 in debt than $30 in debt. -8 is a bigger number than -30. Okay, now I know the magnitude of 30 is bigger, and it's further away from 0, but -8 is a bigger number than 30. Okay, and it's just exactly that. Like, if you think about like how much money you'd rather have, you're going to take the bigger pile. I'd rather owe less money than more money. Okay, that's what negative numbers are, is debt. So what we're going to do is we're going to take, well, -8 is bigger, -8 minus a -30. What happens when we get two negatives together? Right, that's a positive. So 30 minus 8, that's 22. The range is 22. So I like to say range is -8 minus a -30 equals 22. Like, if somebody asked me for the range, that's the answer I want to write down, because it's different. Like, what if I had, we were talking about expenses or something, and that's the same number, right? Now, if you're taking a standardized test, that's all they want. That's all they want. Okay, but I think it gives a little bit more information to say -8 minus -30 is 22, or 1022 minus 1000 is 22. Okay, they're both the same, but this might give you some context to the number and some idea about what you're looking at. Okay, so this is the correct answer. This is what the book wants. This is what a standardized test will want. But I would, if it was me reporting it, I would give you this whole statement. Okay. So yeah, range is positive. Range was not negative here. Can range be 0? Oh, what if we take the example we had up here, where they're all the same, right? The max is equal to 5, min is equal to 5, and we subtract. Range is 0. That means the biggest one is the smallest one. So the range can be greater than or equal to 0. Okay? but it won't be negative. We talk about like physical interpretation of standard deviation. Okay, I'm going to say you know this. Okay, a physical interpretation of the standard deviation, right? It's a measure of spread. It's a moment of inertia. I know everybody at home is looking at that and saying, of course it is. Most of you are like, the heck is a moment of inertia? Okay, maybe in one of the science classes you had, probably before high school, you did conservation of momentum. Looked at an ice skater, and when I say ice skaters or she's right now, doesn't matter, but that's the pronoun I'm going to use. If she has her hands out, right, she has her arms all the way out, then she spins very slowly, right? The distribution of her mass is very, very high because her arms are out. If she's holding dumbbells, it goes even slower because she's got mass all over the place, right? So her resistance to spinning is very high. The resistance to spinning is very high. She's got a high standard deviation, okay? When she brings her arms in, right, then she starts spinning faster. And when you have, right, when you have the arm span like that, right, or your elbows are out, then you start spinning very, very fast. Okay? Your resistance to spinning is less. Okay? That's what moment of inertia is measuring. It's your resistance to spinning. So a high moment of inertia is like the ice skater with dumbbells in her hands trying to spin. Or if you have a very small standard deviation, that is like the ice skater who just has her arms, you know, close to her center line, not a big distribution of mass. Okay. So that's what the physical idea of standard deviation is. Okay, it's just the distribution of mass, and that's how we measure it. Okay. If you ever take physics and you wanted to calculate standard or moments of inertia, the calculation is exactly the same as it is for standard deviation. And so there you go. You're on your way forward to your mechanical engineering class or your physics class to the moment of inertias. Okay. So that's just a little bit preamble about this. Let's do a couple more problems. None of them will care about this. I might ask you a quiz question that asks you like what kind of number standard deviation can be. Just bear with me. I usually put like one or two like ridiculous answers on here. So that might be complex numbers. You've done some of your homework up until now. Has anything looked like this? Have you seen anything in your book that looks like I is equal to the square root of -1? No, you haven't, not in this book. So if you see like complex number 3 minus 2i or a plus bi, something like that, like this is not the answer. Okay, we do not deal with complex numbers and statistics. It's not at this level. Okay, so if you end up with complex number stats, like that's a graduate level kind of class. We're not doing that, right? So if this is one of the choices, you know you can just throw those choices right out. Okay, so it says complex numbers, just that's not the good answer. They also have, you know, they'll say none of the above sometimes. If you're ever going to go into teaching, one of the classes I had a long time ago was something like educational psychology. They said you need a none of the above and a multiple choice answer, but you can't ever like not have it be none of the above. Like you have to follow up with this threat sometimes so that students will know. Like sometimes the answer is none of the above. Okay? So don't look none of the above and say, well, that's not an answer. Okay? So just be careful. All right, let's take a look at. All right, we were getting ready to do number 6 here. I am not a big fan of these problems. Okay, just not. What we're looking at here is grouped data. Okay, so we have a frequency table we have a number of articles, and they want us to figure out the standard deviation of these. Okay. So what we have to do, okay, is we need to find midpoint of each class. Okay, kind of like a histogram, right? So what the way we do that is we take an average out the lower class limits, okay, on both of these values here. So we're going to have 0 through 0.9, 1.0 to, is it 1.9, 2.0 to 2.9, 3.0 to 3.9, 4.0 to 4.9, 5.0 to 5.9. Okay, I think those are our problems there. Sure is. And the way we do that is we average out. So what's the midpoint? The 0 plus 1, right, is 1 divided by 2. So the midpoint is 0.5. Okay, so that was 0 plus 1 divided by 2. What's the next one? It's 1 plus 2 divided by 2. So 1 plus 2 over 2, right, is 3 halves. This is 1.5. Next one, 2 plus 3 over 2, 5 halves, right, is 2.5. I think there's a pattern here you can sense, right? So this one's 0.5, 1.5, 2.5, 3.5, 4.5, and 5.5. I have trust in you. Okay. This would have been 6 if we continued the pattern, right? So we're going to find our pattern, we're going to get our midpoints. These classes all have to be the same size. So once you have like 1, 2, or 3, like you'll be able to guess the rest of them. You don't have to go through and do all of this. Okay. So that's our midpoints. Okay. What are we going to do next? We're going to take our 0.5 times our 1.5 times 2.5 times 3.5 times 4.5 times and 5.5 times. What we're going to do is that we are going to figure out how many articles there are here. So this is going to be 44, 16, 17, 20, 12, and 15. Sixteen, 17, 20, 16, 17, 20, 12, and 15. So what does this equal? Right, let's go through and do all of this. Actually, before I get into doing all this arithmetic with this, okay. The idea is we would use this value to figure out our average value, right? So to get the average, what we would do is we'd say, well, 0.5 times 20 times 44, that's 22. And we do this. Let's do that. Okay, this is going to give me what? This is 1.5 times 16. It's 24. Half of 44 is 22. Okay. 2.5 times 17. Okay, it's 42.5. Okay, so all I'm doing is getting the average here. This is 3.5 times 20. 70. Okay, this is 4.5 times 12. So 54. 5.5 times 15 is 82.5. Okay. If I add these up, right? That'll be my average. Okay. Oh no, I still have to divide by the total number. Okay, but the idea is we would add these up. Okay, so that's going to be 22. Oh, where are we? 22. Really? Are we not doing this today? There we go. Nope, I want the number lock on. Um, 22 plus 24 plus 42.5 plus 70 plus 54 plus 42.5. It's 255 divided by, right? And now we have to add up all of the pieces we have here, okay? So it's going to be 44 plus 16 plus 17 plus 20 plus 12 plus 15. That's my n, right? So this is my total, right, values divided by n. Okay, so we're going to say divided by, parentheses, okay, 44 plus 16 plus 17 plus 20 plus 12 plus 15. Okay, and my parentheses, and there we go. Okay, so what are we talking about with this data? I think that might help us put some context to this. Okay, this was how long it takes to review an article. Okay, and 2.36 months. Okay. Next thing we're going to have to do is we're going to take each of these values, subtract this from it, square it, add those up, divide by n minus 1, and get our standard deviation. Okay, let me show you a different way. So what we're going to do is we're going to go to stat. I'm going to go ahead and check my list. Oh, I got to clear it. Stat, clear the list, clear list 1. Okay, so what I'm going to do now is I'm going to enter in both of the columns. Okay, so we're going to take this guy here as a frequency. So here's our list. So we're going to stat, edit. Now our x values. That was the 0.5, 1.5, 2.5, 3.5, 4.5, and 5.5. Okay. You remember we got them by averaging the lower class loads, lower class limits, right? 0 plus 1 divided by 2 is 0.5, etc. In column 2, right, in list 2, we're going to write in the frequency. It's 44, 16, 17, 20, 12, and 15. Now what we're going to do is we're going to go to stat, calc. Okay, now I told you before, like you only want to put one at a time. This one, it knows that the list 2 is the frequency for the values for list 1. Okay, it knows that. So we're going to do second function list 1, comma, second function list 2. Enter. Okay, so here we can see, right, 2.38, that's our average. Okay, and then our standard deviation here. Standard deviation of the times, variance of the times. Oh, we consider this data to be a population. Okay, so we need 1.78, 1.78, and we're going to square that number to get the variance. Okay, so we're going to say this is 3.17. Okay, and standard deviation, that was 1.78. Okay, check it. Fingers crossed. Right? I type something wrong in, we're gonna, we're gonna feel it. Okay, very good. That's how you do these grouped datas. There'll probably be a few in the homework for you. I don't particularly like the quiz over this question. Mostly, I think it's like this is a 20th century problem, or is 21st? You're not going to be worried about it so much. But yeah, I tend not to worry about trying to quiz over this. Okay, we're going to wait on that one. All right, so hopefully that gives you enough to kind of get through some of your homework here. and it'll give you a little bit of a heads up, like, what's this question for him? Like, yeah, this first one was fine, right? Here's some data. Tell me the mean, median, mode, range, and standard deviation. Okay, it's not too much to it, right? Might be a little bit bigger, but the standard deviation, I expect you to put it in a calculator and give you the answer. I do not expect you to do it by hand. Do not do this by hand. But the rest of these, like that, they're all pretty, pretty reasonable. Probably wouldn't ask you number 6 on a quiz, but it's in the homework, so you're gonna have to do it. But that's how you do it, is you put them in 2 lists and do list 1, comma, list 2. So I'm gonna go out here, and then I will be back in a moment to do the 7, 8, 9, and 10 problems, okay?